There we go. Okay. So this week's topic is going to be on rational expressions. So I'm going to go ahead and pull up the first question. This one is giving us a rational function, and it wants us to evaluate at h of 6. So that just means that we're going to replace every x we see with 6. So I'm going to go ahead and replace all the x's with the 6. And essentially we're just going to end up reducing everything, just multiplying it out and adding, simplifying it down. So starting with the top, I'm just going to break it down. We're going to get a 36 minus 54 plus 8. Then on the bottom, we're going to get 36 minus 72 plus 36. If we combine everything up top, we should end up with a negative 10. And the bottom actually is going to end up giving us a 0. Well, the rule says we can't divide by 0. That's undefined. So we have to categorize this answer as undefined. So does that make sense? Okay, so I'm going to go ahead and pull up the practice, and then let me know when you're finished, and then we can go over this one. Are we ready to go over this one? Okay. So, same as the other one, they've asked us to plug in a negative 3 in for all the x's. So we're just going to replace every x with a negative 3. So negative 3 minus 21. So reducing the top, we're going to end up with negative 9. Then if we just deal with the exponents in multiplication, we're going to end up with 9 minus 12 minus 21. And if we reduce that down, we should end up with negative 24, which would reduce to 8/3. So, yes. All right. So now let's move on to the next one. Now this one is asking us to look at the domain of rational functions. As we saw with the first one, when we got a 0 in the denominator, that was considered undefined. So if they're asking us to find the domain of a function, or the x values that are not in the domain, that's going to have a lot to do with the denominator, not so much the numerator. So we're just going to focus in on whatever the denominator function is and deal with that, so we can figure out the value or values that we're not allowed to use because it'll create an undefined. So with the x squared minus 25, notice that this falls under the category of difference of squares, so we would factor it using those rules. We have x, always a plus and minus, and then our square root of 25 is 5. So when we set that to 0 to see what that equals, we end up with 5 and negative 5. So those are the two numbers we can't use in this particular rational function. Any other number would work except for these two, because if we plug them in back into the original, we would end up with a 0 in the denominator, and we can't have that. Is everyone comfortable with that before I put up the practice? Okay, so put up the practice, and then I'll give you guys a couple minutes to work through this. Does anyone need more time to go through this one? Okay, I'm not seeing anyone saying no, so I'm going to go ahead and go through this one. So again, with domain, we're more concerned about what's happening in the denominator, because that's the one restriction that we have with these, but we can't have a 0. So we're going to be focused on the x squared plus 17x plus 72. Now, if we have a trinomial, then we should be able to use the C method, I guess they call it. When you have that coefficient of 1, you don't really have to go through the whole AC method. So we're able to do our C method, and we're just looking for factors of 72 that would end up adding to give you 17. So that's going to end up being positive 9, positive 8. So when we set that equal to 0, we get negative 9 and negative 8, and those cannot be included in the answer set because they would give us undefined. Is everyone comfortable with that before we move on? Okay. So now we're moving on to the types where they're just wanting us to simplify. So we have a trinomial over another trinomial. So the best way to do these is to just look at it one at a time and just see what you can simplify, if there's any GCFs, or what kind of factoring you'd have to end up using to break it down. So I'm just going to recopy it real quick. So looking at the numerator first, we have another trinomial with a coefficient of 1. There's no GCFs, so we can go immediately to our parentheses. So factors of 24, that equal 11, we're going to end up with positive 3, positive 8. Now in the denominator, we end up actually having a GCF. Everything in the denominator is divisible by 5, so we want to pull that out first. And that leaves us with u squared plus 7u minus 8. So with that GCF pulled out, now we just have a regular trinomial with a coefficient of 1. So recopy everything down here. So now we're able to open our two parentheses. We're going to have a u and a u. So now factors of negative 8 that add up to positive 7. So that's going to be plus 8 minus 1. So now that everything is in factored form, we can find anything that matches, and those would be able to cross out. In this case, we only have the one pair of u plus 8, so those cross out, and we're left with a u plus 3 in the numerator, and a 5 times u minus 1 in the denominator. And as we can see, there's nothing else that matches, no other things that could cancel, so this would have to be our final answer. Everyone is okay with that before I put the practice? Okay, I'll give you guys a couple minutes to go through this one, and then we'll go over it together. Okay, I think we're ready to go through this one, so go ahead and get started. First, I'm just going to copy it down. Okay, so looking at top and bottom separately, the numerator is just a regular trinomial, so that should be able to factor down. So factors of 6, they're going to give us a negative 5. That's going to end up being minus 2, minus 3. Then in the denominator, we have another case where the GCF is something that we want to do first. The top didn't have one, but now the bottom does because they're both divisible by 4. So when we divide out that 4, we end up with v squared minus 9. Now, since we have the two terms, and we have the v squared and 9, which is a perfect square, can be rewritten as 3 to the second, this falls into the category of difference of squares. So we want to factor that like a difference of squares. So that's v and v, always plus and minus, and now the square root of 9 is 3. So we have v plus 3, v minus 3. Now we can cross out anything that matches. So the only thing that we have that matches is the v minus 3. So we cross those out, and everything else that remains is going to be our final answer, because nothing else crosses. We can't reduce this any further. So that's it. Is everyone okay with that before we move on? Okay, so I'm not seeing anyone say that they need more time with that, so we'll move on to the next thing. So now we're going to get into multiplying rational expressions. This one is one just involving monomials, so it's pretty much just going to be matching. With monomials, there's not really anything to be factoring, just maybe cross-reducing would be helpful. Technically, we could multiply straight across, but then we're going to end up with larger values and larger exponents. So if it's possible for us to cross-reduce, that might make it a little easier to do smaller values. So it doesn't really matter which way you start if you want to look at whichever diagonal, as long as you find something that matches that can cross. For example, I just happened to notice that the 5 and the 10, those diagonals can reduce by 5 each. So that would make this a 1 and that would make that a 2. I also noticed that the y's completely cross out. Now we can look at the other diagonal. 3 and 12 can reduce by 3. So that 3 turns to a 1 and our 12 can reduce to a 4, as well as the a's completely crossing out. So now to kind of clean it up, we can always rewrite it. You can rewrite it as many times as you want to, so you don't get too lost with all the stuff that's being crossed out. But we're left with a 1 over 1. So that one pretty much just crossed away. And then for the second one, we ended up with a 4y left over a 2. So 1 times anything is just going to be itself. So we don't really need to worry about that so much. And then we do have another reduction here. 2 goes into 4 2 times. So we end up with 2y. Is everyone comfortable with that before I put the practice? Okay. So I'll give you guys a minute to work through, and if you have any questions, let me know. anyone need more time to go through this one? Okay, so it looks like everyone's ready. So just gonna copy down. Okay, let me try better to make that look like a 6 and not like a B. There we go. All right. So again, it doesn't really matter which diagonal you feel like starting with, but I'm just going to go ahead and look at that diagonal with this one here. Now we have 1c in that numerator and c to the third in that diagonal. So we're only going to be reducing this one by 1, so that one's going to end up still with a power of 2. Looking at the other diagonal, we had a 4 and a 6, which doesn't completely reduce, but they're both even, so at the very least we can reduce them by 2, leaving us with 2 here and a 3 here. That same diagonal still has a b in common. This one has 2, the other has 5, so that one can cross, leaving you with a third power here. Now, if you wanted to, because we also have not just diagonals, but from top to bottom, there could be some reduction as well. So it's up to you if you feel more comfortable with rewriting it and making it look a little cleaner first before you keep reducing. But we do have a C that can cross off that 2 and leave us with just 1 on the bottom. So now let's go ahead and rewrite what we have left over. We have a 1 over 2 times 3b cubed over 5c. So now that it's cleaner, it's easier to see that it doesn't look like we have any more things that could cross-reduce or reduce from top to bottom. So now is a good time to just go ahead and multiply straight across. 1 times 3b cubed is going to remain the same. And a 2 times 5c is going to give us 10c. So none of these things have anything in common anymore, so we know that we can call this the final answer. Is everyone comfortable with that? Okay, so the next one is still going to have to do with multiplication, but now, instead of doing monomials, we're going to be multiplying with polynomials. So the idea is still going to be the same, but this one's kind of going to start throwing in some of that factoring. So let me get it copied. The easiest way to see if we're going to have anything to cross-reduce before just trying to multiply this, because we're going to have with huge numbers if we try to multiply it now, the best thing to do is to go to each part separately, each numerator and denominator separately, and see if there's anything we could factor or simplify first before trying to multiply. So with this first one, the x plus 2, there's nothing really that can be done, so that one is going to stay the same. But the denominator to that fraction is a trinomial, so that should be able to factor down. And so we're looking for factors of -2 that equal -1. So we're going to end up with x and x and +1 minus 2. Then we're going to look at the other numerator, the 3x plus 3. It doesn't really fall under the category of trinomial or difference of squares or sum of cubes or anything like that, but we do have a GCF, so that is definitely something we'd want to take out if possible. And that would leave us with 3 times x plus 1. Then the denominator x minus 3, We can't do anything with it just like that, so we're just going to transfer that. Now that everything's in factored form, it's going to be much easier to actually see what these things have in common. So we can see that the x plus 1s were in common and they're diagonal, so they're able to cross out. But it looks like nothing else will reduce. Nothing else matches. So we'll just have to go through with our multiplication. Okay, there we go. So if we multiply across the top, we just want to keep that, that coefficient out in front of the parentheses. And then we have x minus 2 times x minus 3. And nothing else reduces, so that's just going to be the answer. So here's the practice for you guys to try. I'll give you a couple minutes, and then if you have any questions, you can always let me know in the chat. Are we ready to go over this one? Okay. So let me get a copy. Okay, so same idea with this one. Just go a section at a time and see if anything's factorable. So that first numerator is going to be factorable. It's a trinomial. So we're going to open up our two parentheses, and it's going to be x and x. And now we need factors of -3 that add up to 2. So that's going to end up giving us a +3 minus 1. The denominator to this fraction is another trinomial, so we're going to end up with 2 parentheses. And now we need the factors of 6 that add up to -5. So that's going to be -2, -3. And that factors our entire first fraction. So now we want to make sure that the second one is fully factored as well. We can't really do anything at this point with the x minus 3, so we just transfer it over. But the 4x minus 4 has a 4 in common between the two terms. So we can factor that out as a GCF, and we're left with x minus 1. So now we can look for anything that matches, and we do have a couple. We have the x minus 1s are gone, and the x minus 3s. So now the only thing left in the numerator when we multiply through is an x plus 3, and then we're going to have a 4x minus 2. Nothing else matches, nothing else is the same, so this is the final answer. Everyone is comfortable with that? Okay, so we're going to end up finishing a bit early. We only have one more question to go through, which is dividing the rational expressions. So this is just going to end up being a short session, I guess. So here's our last type of problem, which is essentially going to be the same. It's just division, so there's a little extra setup that we have to do in order to solve this. So I'm going to go ahead and copy it. Okay. So one of the first things we want to do anytime we're dividing two rational expressions is, instead of writing this as a division, it would be the same thing to say multiplying by the reciprocal. So we've just done quite a few problems with multiplication. It's going to be much better for us to just go ahead and flip and treat this like a multiplication. So the first one's going to stay the same. Some professors might have taught you this as the keep, change, flip. Same thing here. You keep your first, change the operation to multiplication, and then you flip your second. So now the trinomial comes up top, and your x plus 2 is going to be on the bottom. And that's going to create a multiplication instead. And then from there, it's exactly what we've been doing before. We just take it a piece at a time and try to factor or simplify it down. So the x minus 3 is going to be the same. The 3x plus 3, the only thing that we can do is pull that GCF of 3 out. So we take that out and we get x plus 1. The second numerator has a trinomial, so we're going to have to end up factoring. So now we need the factors of -2 that equal -1. Okay, I got confused for a sec. I thought I pulled up the wrong question. Okay, now I got it. All right, so we get x minus 2 and then x plus 1 to factor that. And then we can't do anything at the moment with the x plus 2, so we're just copying it down. Now we should be able to cross anything that matches. So we've got an x plus 1 and an x plus 1. Everything else doesn't seem like we can cross anything. Nothing else seems to match. So we can go ahead and multiply straight through. So we have x minus 3 times x minus 2 all over 3 times x plus 2. And again, nothing matches, so that's all we can do. So now for the final question, I'm going to put up the practice, and this will be the last one for tonight's session. So I'll give you guys a couple minutes, and then we will go over it. Are we ready to go over this one? Okay, I'm not seeing anyone say no, so I'm just going to copy it down and then we'll go through it. Okay, so since we're still dividing two rational expressions, we're going to do the same thing, the change flip. So the first one stays the same. Change that to multiplication, and then the second one is going to flip. And so now we're ready to factor everything out. So the first numerator is going to be a trinomial. So we're going to have x and x, and then factors of -6 to equal +1. So we're going to get -2 plus 3. And then the x plus 1 stays the same. Multiply that by taking out the GCF of 4. We get x plus 1. And then that denominator is going to end up being a difference of squares. So we have our two parentheses. X, there's always going to be a plus and minus with the difference of squares. And then the square root of 9 is 3. So now we can cross out any like factors, so the x plus 1s and the x plus 3s. Doesn't look like anything else is in common, so we'll just go ahead and multiply through. So we want to put the numbers first. So 4 times x minus 2, and then in the denominator all we have left is x minus 3. So nothing else is in common, and that's that. So does anyone have any questions on this or any other question from the entire session? So yeah, so it looks like if no one else has any questions regarding the stuff that we just covered, then that's it for this session. So yeah, that's it for tonight's session, and then we'll have the next one on Sunday, same time.